Hello students. In the last class, we are studying about the IUPAC system of nomenclature in the basic principles and techniques. Just to recollect, I told you in IUPAC system of nomenclature, there are 5 words: primary prefix, secondary prefix, root word, primary suffix and secondary suffix. Okay, you recollect that what all the terms before we go for examples today. Primary prefix stands for is it contains a cyclic structure. Secondary prefix stands for the different substituents attached to the carbon chain. Root word stands for the number of carbon atoms based on the parent alkane chain. We use the word meth, eth, prop and so on. Primary suffix is only 3 different words. I told you, if it is having a single bond ane, double bond ene, triple bond ine. And the last one, secondary suffix, stands for the functional group. Based on the function group, the IUPAC system of nomenclature ends there. Okay. So after understanding that 5 words, I told you about the different rules. In the 5 different rules, I told you already the first one, that is a longest chain rule. We have to number the carbon skeleton in such a way that we will get a maximum number of carbon atoms, especially applicable in the branched chain structures. The second rule, I told you, the lowest sum rule. If the parent alkane chain contains a more than one substituent, the numbering, is it from left to right or right to left or in different directions? It depends on the lowest sum rule. I think you understood that also. The next rule I told you, alphabetical order of the substituents. Whenever more than one substituent is present, we have to follow alphabetical order. And fourth one I told you, if suppose the same substituent repeats, methyl group present twice or a halogen present twice, then we use the prefixes like a di, tri, tetra, etc. Okay. So after understanding these 4 rules, let me continue with the 5th and the last rule today, that is order of priority. Now you will ask, what is this priority order here? Whenever there is a more than one functional group present in the carbon chain, which is to be the order of priority to be followed. Remember the sum of the function groups. So you know there are so many functional groups you have to remember. Okay, the functional group is nothing but a group of atoms which will decide all the chemical properties. When you say you heard about organic compounds like alcohol, aldehyde, ketone, ester, carboxylic acid, amine, amide and so on. There are so many functional groups. Even in the benzene derivatives we come across phenol and other derivatives also. Now what is the order of priority? Suppose if there are 2 functional groups present. Okay, now let me give you an example before I teach you about the order of priority. Suppose if I write a carbon chain like this. Okay, now as usual, when you know that carbon chain is present like this, 1, 2, 3, 4, 5, 6, 7 carbon atoms are present in a straight chain. Longest chain rule is not applicable, lowest sum rule is not applicable, and other rules are applicable, only I fill the valences of the carbon atoms. Okay, now say for example I'll write COH here at one end of the carbon chain, and let me write OH group here on the other end of the carbon chain. Okay, now to fill the remaining valences I'll write here CH3, 3 bonds are present, so 1 more is H. For rest all hydrogen, the 2 hydrogen atoms present here, CH2, CH2 like this. Okay, now the question you will ask, how to number this carbon chain? Okay, so whether you have to number it from left to right or right to left, the one more simple rule what you have to understand, you have to number it in such a way there should be lowest number given to the functional group. Okay, now only confusion with all of you that one functional group is visible here, that is a carboxylic acid, and another functional group is OH group here. Okay, just for your information I am telling you, this is carboxylic acid, this is alcoholic group, both are functional groups only. Okay, now if you give importance to the alcoholic group, you must number it from left to right. If you are giving importance to the carboxylic acid, you must number it from right to left. Okay, the question is, if there is only one functional group, suppose the OH group is not there, you must number it from right to left only. Suppose if that COH group is not there, instead of that some CH3 or something else is there, you have to number it from left to right. Okay, now the question is, among these 2, which is to be given priority? That's what I wanted to tell you. Lowest number should be given to the functional group, no doubt, but when there is a more than one functional group is present, we have to follow the order of priority. This is very important because most of the time when question comes in the exam, They will not give a very simple examples where only one functional group is there. Okay, they may give in a bond line representation, but see that if there is a more than one functional group, what is the order of priority to be followed? It's a very important even for the competitive exam when you study. So remember this sequence, the order of priority. The first comes a sulfonic acid, SO3H. Then comes a carboxylic group, means it is in the decreasing order of priority. This is to be given more priority. So whenever SO3H group is there, you have to give priority to that. Then carboxylic acid. This CO is nothing but ester. CONH2 is amide. CN is a cyanide. We say in IUPAC system we call it as a nitrile. CHO is aldehyde. C double bond O is a ketone. Okay, both will have a carbonyl group, but it is aldehyde and it is ketone. Then comes a alcoholic group. Then comes amine. Then comes a double bond and triple bond. There are some examples where there is no functional group like some different substituents. Then double bond, triple bond also considered as a functional groups. Okay, so this is the order of priority. You must remember at least this much. Students, I am not telling this. These are only the functional groups. There are many more, but at least this much you have to remember the order of priority. Okay, now coming back to the one example what I told you. There are two functional groups present, that is carboxylic group and alcoholic group. Okay, so when these two are present, which is to be given priority from this list of the priority what I wrote you before? Here carboxylic acid should be given priority, then the next preference goes to alcoholic group. So according to that order of priority, we must give importance to the carboxylic group. So this is the first carbon atom. Are you understanding? We have to number it from right to left, even though the function group present here, because among these two, carboxylic group is given priority. That's the first carbon atom, this is the second carbon atom, third one, fourth one, fifth one, sixth one, and seventh one. The number of carbon atoms is not changed. So you understood, it must be numbered from right to left because the priority goes to the function group carboxylic acid. So now how to name it? Try to recollect all the words and different rules we studied. There are 7 carbon atoms. The root word comes, what is the root word for 7 carbon atom? You remember meth, eth, prop, but, pent, hex, and this is hept. There are 7 carbon atoms, so hept. Between the carbon atoms there is only single bond, so en. Okay. Now I told you among these two the functional group is carboxylic acid only. So the next comes the En, where E we replace with the OIC acid, that you remember, it becomes oic acid, heptanoic acid. But we didn't mention anything about the hydroxy group here. Okay, remember the words what we use. When the OH group is a functional group, is a major function group, then the name of the compound ends with OL, alcohol. If it is present as a substituent, means it is a second functional group. Now the name of this is hydroxy. So 6th carbon atom having hydroxy group, so we will write it as 6, that is a position where the OH group is present, hydroxy. Okay, so the IUPAC name of this compound will be 6-hydroxy heptanoic acid. Okay, so remember the order of priority and accordingly you can easily name n number of organic compounds in IUPAC system. Okay, especially when there is a more than one functional group, you have to understand how to start naming. Okay, how to number the carbon chain, that is the first thing. Second thing, what is the order of priority? Okay, so if you understood this, let me give you one more example. We will discuss if there is a 2 function groups present, how you can name them. Okay, going to this next example, let me write a carbon chain like this. Okay, just I am creating an organic compound. Okay, see that how you can go ahead with the naming them. Okay, suppose I will write here alcoholic group at one end of the carbon chain. Okay, here I'll write CH3 group. Then here I'll write cyanide as a substituent, which is a functional group. Rest all I'll fill the valency. This is CH2. These 3 bonds are there. This is CH. 3 bonds are there. CH. This is CH2. That is CH2. I already wrote. Okay. So when you want to number this carbon chain, you must know the order of priority. Okay. Looking at that, It is easy. Suppose you consider this substituent in numbering or this, there is no difference. So longest chain rule, lowest sum rule is not that much applicable, but we have to understand the lowest number to the functional group and the order of priority. As soon as you look at this compound, you can see there are two functional groups like this. Yeah, one is a cyanide or a nitrile, other one is a hydroxy group or alcoholic group present as a substituents. So among these two, which is to be given priority? Again, sticking on to the rules, I will give you so many examples later. You have to start answering for them. Okay, how to name it. But here you try to understand, among cyanide and alcoholic group, which is to be given priority? I told you cyanide comes first and then alcohol. So we have to give importance to the functional group like cyanide, and then priority goes to OH. Okay, now if you are giving lowest number to the function group, are you starting numbering from left to right or right to left? There is also a question. Okay, so this is a first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom, 5 carbon atoms are there. So if you number it from left to right, 1, 2, 3, 4, 5. Okay, if you number it from right to left, this is a first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, and fifth carbon atom. Okay, so the question arises now, is it numbering from left to right or right to left? Because the major functional group cyanide falls on the third carbon atom only if you number it in any direction. Okay, now take the advantage of the lowest sum rule. Okay, apart from that functional group, there are other two substituents also. Okay, what are the other two substituents? One is a methyl group here and one more is a hydroxy group. Okay, so use the lowest sum rule. If you number it from left to right, it is a second carbon atom, third carbon atom, and the fifth carbon atom having a substituents. Okay, when you number it from left to right, it is a second carbon atom, third carbon atom, and fifth carbon atom having substituents. So 2, 3, and 5. So when you add that, the sum comes as 10. When you number it from right to left, okay, see the positions. This is a first carbon atom where the hydroxy group is present, third carbon atom having other substituent, and fourth carbon atom having a next substituent. 1, 3, and 4. Got it? The first carbon atom having a hydroxy group, third carbon atom having a cyanide group, fourth carbon atom having a CH3 group. So 1, 3, 4. Okay, so it becomes again 8. So according to the lowest sum rule, you have to start numbering it from right to left only, not left to right. So this is wrong if you number it from left to right, because the lowest sum rule is applicable. Okay, so we numbered it, we got the substituents, and we have to follow alphabetical order as well as a priority to the function groups. Okay, so now we understood the total number of carbon atoms is 5. So the root word comes as pent. Between the carbon atoms, there is only single bond, ane. Okay, understood? So rest all the substituents there, but remember, whenever the functional group present on particular position, you have to mention the position where the functional group is present. If it is on the first carbon atom, you no need to mention, but if it is any other carbon atom, you have to mention. So third carbon atom having a nitrile group, so pentane, 3 nitrile. Nitrile is a functional group for cyanide, CN, whatever, right? So third carbon atom having that, so I said 3 nitrile. Now important thing is, what are the other substituents? Okay, so first carbon atom having a OH group, fourth carbon atom having a methyl group. So we have to say hydroxy and methyl. Now among these two substituents, alphabetical order follows. So this is methyl, the substituent name starts with M. It is hydroxy, substituent name starts with the H. So order of priority if you follow, first comes the hydroxy. So even though substituent present at the first position, you have to mention that, because it is not the functional group now, it is a second function group. So it is 1 hydroxy. Understood? This is the first carbon atom having hydroxy group, so 1 hydroxy. Then fourth carbon atom having a methyl group, so 4 methyl. P will be small letter only, not a capitals in between. Okay, only the first letter in the starting we write capital. So 1 hydroxy, 4 methyl, pentane, 3 nitrile. Okay, I hope you understood. there is two substituents, that is hydroxy and methyl group, one functional group, so altogether 3 substituents. Even though there is a straight chain, we used lowest sum rule, we numbered it from right to left, and we gave importance to the nitrile group as a substituent, which is a function group, and other 2 acts as a substituents only, and we named it according to IUPAC system. So n number of examples can be created like this. More than one function group is present, so you have to understand. I hope you understood the concept first, and we can go for n number of examples, how to number it, how to name them, and what all the different substituents to be used. All those you can easily understand. But see that order of priority, this is very important, because many times you will forget this. When 2 function group is visible, then if you are not knowing the order of priority, you can't proceed easily. Okay, and I told you earlier, whenever there is no substituents like this present as a functional groups, there may be possibility just a double bond and triple bond becoming a function group. Okay, only double bond, triple bond also acts as a function group, and among that you have to give importance to double bond, then to the triple bond. Just like a bond line representation sometimes given like this. Okay, I may give double bond here, I may mention triple bond here, like this. Okay, now you may think how to represent this structure. Okay, it is at the terminal positions only 2 different bonds are present, and you can number it from left to right or right to left, but order of priority goes like first double bond and then triple bond. So it is a double bond at this end and this is a triple bond. Okay, don't think like what is this? This is actually a bond line representation. When you number the carbon atoms in the parent chain, you will get an idea what is that. So giving importance to the double bond, we start numbering from here. It is the first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, this is a fifth carbon atom. So it has got 5 carbon atoms in the parent alkane chain, so it becomes a pent. Okay, so there is no other substituent, that means there is no secondary prefix. Anyhow, the primary prefix is not there, it is not a cyclic structure, secondary prefix is not there, both these are functional groups. Okay, so the name starts with the pent because there are 5 carbon atoms. Okay, then no need to say ANE9 because that functional group itself is a double bond and triple bond. I told you priority should be given to double bond, okay, and then to the triple bond. So ending will be the functional group, so we say it is pent 4 ine, then 1 ene, like this. Whenever the multiple bond is present, we have to understand the order of priority, double bond or triple bond is present. So many such examples in the bond line representation may be given. Okay, see that how you number the carbon skeleton. Are you clear? This is simple about the IUPAC system of nomenclature. We understood the different rules, and next class I'll give you some examples. You have to know how to number the carbon skeleton and name it. Okay, thank you.